So today we are doing trig functions of any angles, and more specifically we're doing them on the coordinate plane. Our angle is always between the slanted line and the x-axis. And then it's kind of hard to see, but it gives us a coordinate point xy. So I'm going to redraw this triangle. I have my theta is my angle right next to the origin. If I'm looking at this, I'm going x coordinates left and right, and I'm going y coordinates up and down. So this is kind of looking like what we were doing with 9.1. I have my Pythagorean theorem still, but I've replaced A, B, and C with x, y, and r, all for my radius. So on this picture, the slanted line is my r. And then I have my same 6 trig functions, and instead of the words opposite, hypotenuse, and adjacent, I've replaced them with the letters x, y, and r. So I still have my same 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. Instead of being opposite over hypotenuse, it's now y over r for sine. Cosine, instead of being adjacent over hypotenuse, is x over r. Tangent, instead of being opposite over adjacent, is y over x. Cosecant is r over y instead of h over a. Secant is radius over x instead of opposite or hypotenuse over adjacent. And then cotangent is adjacent over opposite x over y. Once I have my coordinate points and I find my radius, I can plug back into these formulas to get my trig values. So, number 1 is telling me negative 4, negative 4, positive 3 is a point on the terminal side. So what that means is my x value is negative 4, my y value is 3, and then I need to solve and find my radius. So what I want to do is I want to go ahead and plug into my Pythagorean theorem. I have negative 4 squared plus 3 squared equals r squared. Negative 4 was my x, 3 was my y. Negative 4 squared gives me positive 16. This is because I have 2 negatives, and a negative times a negative makes a positive. 3 squared is 9. R squared is still r squared. (16 plus 9 gives me 25. Then to get r alone, I want to take the square root of both sides. 5 gives me r. 5 is r. So if I go back, I can label this, and this is my r. Now I want to plug into my 6 trig functions that I have up here. So sine is y over r. So my y was 3, my r was 5. This matches up with my opposite over hypotenuse. Then I have my cosine. This one is x over r. So my negative 5, or negative 4 over my 5. My adjacent over my hypotenuse. I have tangent of theta, which is opposite over adjacent, so y over x, which is 3 over negative 4. I can write it like this, or I can pull that negative out front in front of the 3. Then I need to go get my reciprocal functions. I have cosecant matches up with sine. This one is going to take my sine and flip it, so it's going to be 5/3. Or if I wanted to use the formula up above, it's radius over my y, so 5/3. Then I want to get my secant. This is flipping cosine, so instead of -4/5, I can have -5/4. Then I have my cotangent, and this one flips my tangent, so I would have -4/3. Questions here? Yep. Okay. So number 2 tells me 8, -6 is a point on the terminal side. So what I would want to do is plot this point like it's on the graph, and then connect it to make a triangle. I have 8 for my x, -6 for my y, and then I have my radius that I still need to go solve for. So the first thing I want to do here is plug into my Pythagorean theorem. I'm going to have 8 squared plus -6 squared equals r squared. Then I want to figure out what 8 squared is, which is 64. -6 squared is going to give me a positive 36. R squared stays r squared. (64 plus 36 is 100. Gets me r squared. Then I want to take the square root of both sides. If I know the square root of 100 is 10, but if I forgot, I can go to Desmos. I can type the letters SQR, and then when I hit T, it gives me the square root symbol. Or I can click this keyboard down here, and I can click the square root symbol and type in 100. So my square root of 100 is 10. I'm going to go fill this in on my triangle. Then all I want to do is plug these into my formulas from up top. So I am going to have sine of theta. This one is y over r, or opposite over hypotenuse. So -6/10. Notice both 6 and 10 are even. I can go ahead and simplify this fraction. I could divide by 2 by myself, or if I want, I can go to Desmos and type this in. And then once I get this, I hit the fraction button, and it turns it back into a simplified fraction, which is -3/5. I can go ahead and do the same thing for cosine. This one is x over r, or adjacent over hypotenuse. This x is 8, the r is 10. This one will simplify again, so I can type it into Desmos. Which gives me 4/5. Then I have tangent, which is opposite over adjacent, or on the coordinate plane, y over x. So my y was -6, my x was 8. Then I want to go ahead and simplify this. So I'm going to go back to Desmos. which turns into negative 3/4. Okay, then I can go ahead and do my reciprocal functions. I have cosecant. This one is r over y, or it's the reciprocal of sine. So I can just take my answer from sine and flip that fraction. So I'm going to have the 5 on top and the negative 3 on the bottom. I don't know why I boxed the word. Then I can do the same thing for secant. This one is the reciprocal to cosine. So I flip the cosine fraction. I'm going to have 5 over 4. Then I have cotangent. It's the reciprocal of tangent. This is 4, negative 3. So I will move on to the back. On the back I have something called the unit circle. What this is, it is a circle with a radius of 1, and it has a center at 0, 0. When we're working in the unit circle, everything follows these patterns below. My radius is 1, so I had all of these from the front side. I had y over r. If I replace that r with a 1, anything divided by 1 is always itself. So sine is just the y value on the unit circle. The same thing for cosine. When I divide by 1, it just turns into x. My reciprocals switch with the 1 on top. And then tangent and cotangent stay the same for my coordinate planes. So what this is it's a circle. It shows me at different angle measures. It gives me the radians on the outside, degrees on the inside. And then it gives me the x and y values at those different points. So number 3 wants me to use the unit circle to evaluate the 6 trig functions at 270 degrees. So I'm looking at the inside degree numbers for 270. That is right here. So I'm going to sketch this on my paper and then mark only the 270 degree point so I know where this is. This is my x. This is my y. Because it tells me it's a unit circle, I know my radius is 1. So then I am just going to go ahead and plug into these 6 functions I have up above. My sine of theta is just my y value, so negative 1. Cosine is just my x value, which here is 0. Tangent is y over x, so negative 1 over 0. So when I try to simplify this fraction, I can't divide a fraction by 0. The thought process here is if I have a group of, let's say, like all of you guys, and I wanted to break you guys up into 0 groups, I can't do that because by default, I at least have to have you in your group of yourselves. So I can't break you up into no groups. This means whenever I have a 0 on the bottom, the answer is undefined. And this only happens when I'm dividing by 0. Then I can do my reciprocal functions. So I have cosecant. This is 1 over the y value. The y value here was negative 1. So 1 divided by negative 1 simplifies to just negative 1. Then I can do my reciprocal for cosine, which is secant. That's 1 over x. My x value here was 0. So again, I have a 0 on the bottom. My answer is going to be undefined. And then finally, I have my cotangent, which is x over y. So 0 over negative 1. This one, it's okay to have a 0 on top, because if I have nothing and I try to split it into one group, I still have nothing. So when I simplify this fraction, it just turns into 0. Questions here? Okay. So number 4 is the same thing, except this time it gives me the radians. So I want to look at the outside of my circle, or the outside, inside numbers. So I have a pi half, I have a pi, I have a 3 pi halves, and it doesn't keep going, but the pattern here is to keep counting by a half. So over here I would have 4 pi halves, and if I kept going, this would be 5 pi halves. So this is the coordinate point I care about. This is my x, this is my y. Because it's a unit circle, my radius is 1. Then I am going to plug into those trig functions. So sine of theta is just my y value, which is 1. Cosine of theta is just my x value. The x value here is 0. Then my tangent is y over 0. So 1 over 0. I have a 0 on the bottom, which gets me undefined. Then I want to get my reciprocal function, so I have cosecant, which is 1 over y. Y was 1, so 1 divided by 1 is just 1. Then I have secant, which is 1 over x. My x was 0. So this one is undefined, because I have that 0 on the bottom. And then finally, I have my cotangent, which is x over y. So 0 over 1, which just simplifies to 0.